Assalamu alaikum students. Welcome to Train Your Brain. Today we study about OSI physical layer. First of all, we see a small structure in which we have application layer, presentation layer, session layer, that is software layers. Transport layer is a heart of OSI. Network layer, data link layer, physical layer. It's a hardware layers. I again repeat: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and last one is physical layer. Next we have function of the physical layer. The physical layer is responsible for sending computer bytes from one device to another along the network. It does not understand the bytes, rather its role is defining how physical connections to the internet are set up and how bytes are represented into predictable signals as they are transmitted either electrically, optically, or via radio waves. To do this, the physical layer performs a variety of functions, including defining bytes, determine how bytes are converted from 0s to 1s to a signal, data rate, determine how fast the data flow in bytes per second. Synchronization ensure that sending and receiving data are synchronized, that is transmission mode and interface. Next we have types of transmission media in data communication technology. A transmission media is a physical path between the transmitter and the receiver. For example, it is a channel through which data is sent from one place to another. Transmission media is broadly classified into the following types: guided media and unguided media. In guided media we have twisted pair cables, coaxial optical fiber cable, strip line, and micro strip line. Unguided media we have one type, that is phase. Next we have transmission modes in computer networks: simplex, half duplex, and full duplex. Transmission mode means transferring data between two devices. It is also known as a communication mode. Transmission has three types: simple mode, half duplex mode, and third one is full duplex mode. Transmission mode means transferring data between two devices. It has known as communication mode, that is simple, half duplex, and third one is full duplex. Next we have simple mode, simplex mode. In simplex mode, the communication is unidirectional as on a one-way street. Only one of the two devices on a link can transmit, the other can only receive. Example: keyboard and traditional monitors. The keyboard can only introduce input, the monitor can give the output. It's a example of simplex one direction. Simplex mode, the communication is unidirectional as on a one-way street. Only one of the two devices on a link can transmit, the other can only receive. Keyboard and traditional monitors are example of simplex. Half duplex mode. In half duplex mode, each station can both transmit and receive, but not at the same time. When one device is sending, the other can only receive, and vice versa. The half duplex mode is used in cases where there is no need for communication in both directions at the same time. Example: walk and talk, in which messages sent one at a time and messages are sent in both directions. First diagram is A is sending, B is receiving. In second diagram, B is sending, A is receiving. It's an inverse process between sender and receiver. Next we have full duplex mode. In full duplex mode, both stations can transmit and receive simultaneously. In full duplex mode, signals going in one direction share the capacity of the link with signal going in other directions. This sharing can occur in two ways. Either the link must contain two physical separate transmission paths, one for sending and the other for receiving, or the capacity is divided between signals traveling in both directions. Full duplex mode is used when communication in both directions is required at all the time. In full duplex mode, both stations can transmit and receive simultaneously. It's a diagram, both directions are PC and terminated. Analog digital. Digital signal. A digital signal is a signal that represents data as a sequence of discrete values at any given time. It can only take on one of a finite number of values. Analog signals. An analog signal is any continuous signal for which the time varying future of the further of the signal is representation of some other time varying quantity, for example analog to an other time varying signals. Next we have multiplexing. Multiplexing is a technique to mix and send multiple data stream over a single medium. This technique requires system hardware called multiplexer for multiplexing the stream and sending them on a media, and demultiplexer which take information from the media and distribute to different instructions. Design issue with physical layer. The physical layer is connected with transmitting raw bytes over a communication channels. The design issue has to do with making sure that when one side sends a 1 byte, it is received by the other side as a 1 byte or not as a 0 byte. So today lecture is end. I hope you like my lecture. If you are new on my channel, then like my channel and subscribe my channel. Take care of yourself. Remember me in your prayers. Allah Hafiz.